Okay, we'll be working on chapter 7. We're going to look at bonds. We're going to do the Sim Excel sheet. Just a reminder, you have to do the process how I do it. You can't just plug in the numbers, or at least the answer. You can't plug in the answer, it's not going to work. It's only going to work if you do the process. Got to have to be exact number. All right, let's go straight to it. So you can download the Sim chapter 7 Excel sheet. This is a basic bond here. So it says Drew's company bonds mature in 8 years. So you kind of want to plug those values in as you go. It has a par value of 1,000. That's pretty typical. And a lot of these questions will just be 1,000 par value. And then it gives you, instead of calculating the coupon payment, it gives you the coupon payment of 22. And then the interest required by investors is 8%. So what we're going to look at, we're looking at the price, or in other words, we're looking at the valuation as an investor. What do I value these future cash flows today? And it's based on 8%. So whatever that value is, that means if I pay that price, I gain 8%. Periodic payments, this is an annual coupon. So that's going to be 1. And then total payments is just years times periodic, which is the 8. So now we could solve for the price. So I'm going to say equals. It's the present value of all future cash flows. So we're looking at the present value. The first thing we want to look at is the rate. Now this is an annual payment. Therefore, the interest is annual. So that's what we want. Next is total number of payments. Next is our PMT, which is the coupon payment. And then last is the par value. Plug it in. So what it's saying is if I require 8%, the most I'm willing to pay is $666.69 if I require an 8% return. Assume that you are considering to purchase a 10-year non-callable bond, and we'll do the callable ones in a second. With an annual coupon rate of 8.66, the bond has a face value of 1,000 and it makes semi-annual interest payments. If you require a 6% nominal yield to maturity, that's what I require as an investor. What is the maximum you're willing to pay for it? So let's plug some values in. First off is the par. The required for investors is 6%. This is a 10-year semi-annual. Look at that. This is going to be paid interest payments twice a year. So we got to make sure we do twice a year there. And then this darker gray means it's a calculated field. So we want to know what is the total number of payments, which is going to be the years times the periodic payments. So 10 years, we make 2 payments per year for 10. That's 20 payments. And then the coupon rate, which is 8.66. And then we got to solve the PMT. We cannot use the PMT function in Excel, but we have to use this equation. So we're going to say it's 8% times 1,000, so 8.66. So we get 8.66% of 1,000 each year. Well, it's split up 2 different payments. So we have to divide it by 2. And then that's going to be our PMT. So that is roughly 86 per year, but we get every 6 months, we get about 43. All right, and then we want to do the price. So the price is the present value. First thing I want to do is the required rate of return. That's the rate. However, this is semi-annual payments. So these payments are in 6 months. Therefore, I have to put the interest in 6 months. So I'm going to divide the interest by 2. Because if you don't do that, it assumes that it's 6% every 6 months, but we're not getting that. We require 3% every 6 months. Total number of payments, 20. Our PMT is 43. And then the future value is the par value. So the most we're willing to pay is $1197.87 for this one. Just want to show you, if you typed in 43, it does not work. How I developed it, you have to do it exact, or that's not going to work. Okay, Billy Bob's bonds currently sell for $1,200. They pay 8% semi-annual coupon, 20-year to maturity, and have 1,000 par value, but can be called in 5 years for 1,075. So what this is going to be a normal bond, and then we're going to look at what is yield to call. So what is a call? A call is an option that the one who issued the bond, the company, the Billy Bobs, they could end the contract with you sooner. They can call it within 5 years instead of the full 20. Why would they do that? Well, things changed in the market. So, more than likely, what happened was interest rates went down, and they said, I could retire this debt and instead issue new debt at a cheaper rate. So if they have that, it has to be a provision in the contract, and they have to pay you. Look what they're paying you: 1,075 at the end of the contract in 5 years instead of 1,000 par value. All right, so let's plug numbers in. The price we paid 1,200. Now this, what I did was, what we're trying to solve here. We're trying to solve the rate because we have the price, we have all the variables, and we want to know what rate of return. So 2 ways to make money in a bond. You can make it on the interest payments, the coupon payments, and you also can make it on the capital gains, which means you buy it less than 1,000. So what we have to do, we're paying more than 1,000, and how Excel recognizes it, you have to do your inflows and outflows correct. So if this price is what we're paying, which is a cash outflow, I have to have it as a negative because that's an outflow money. Anytime I'm receiving money, which is the 1,000 and the interest payments, that's an inflow, which is positive. So then we want to, we get 8% of par. Let's do the par value, 1,000. Periodic payments per year. That was, I forgot what I read there. So say semi-annual. I'm going to correct that. A semi-annual coupon payment. So that's going to be periodic payments will be 2. 20 years. Oops. Total number of payments would be 40, right? 20 times 2. And now we can solve what's the coupon payment? What's the payment that we receive interest payments? Well, that's all it means is it's that coupon rate. You don't see it there, but it's the cell above E10. And then that's times par value. So it's the 8% of par. We're receiving $80 per year. However, we want to know how many times do you get payments of that 80? You get it twice a year. So it's split of 2 payments of 40 per year. And now what we can do is solve the yield to maturity. Remember what I said, the total number of payments and the rate must be in the same period. So if this is semi-annual, this is real important. Remember what we did before for price? I had to divide it by 2 to get the interest rate. So I want you to think about that when I'm solving rate, yield to maturity. So I'm typing rate. First thing, ask for total number of payments. That's twice a year, right? It's 20 years, but 40 payments. Next is PMT, which is the 40. Present value, that's got to be a negative. So if you don't have it as a negative, you have to type a negative in front of that. But really, we already have that as a negative. Par value. Now, if I close this up, it's not going to show correct. Why? Because anytime it has a yield, that's a yearly return. However, since this is semi-annual payments, that's a rate of every 6 months. So what I'm going to do is, if you look at the formula tab up there, I'm going to multiply that times how many payments per year, because that's what we're in semi-annual. So that's what, 3 point something percent. So it's really multiplied times 2, 6.24%. So that's how that works. Next, if the company calls it within 5 years and they pay us 1,075, what was our yield to call? How much did we make for those 5 years per year? So let's plug some numbers in. They can call it within 5 years. Now we want to know, what is our PMT? That's the 40. You know what? I think I made a mistake. Yeah, I made a mistake there. I shouldn't say PMT there. I got to take that off. I'm going to do that right now. I remember seeing that last year and I forgot to correct that. All right, bear with me for a second. Let's do the formatting. Okay, what it's saying is total number of payments. What does that mean? Total number of payments. That is, if they call it, what is our total number of payments? I didn't have to put PMT there because we already have PMT. So what I mean by that, total number of payments is if they call it within 5 years and you do 2 payments per year, that's going to be 10. And then what is the price to call? Well, that's the 1,075. Now we could plug and find out what that is. Keep in mind, this is a semi-annual payment, so this is going to be the interest rate every 6 months. So I'm going to say equals rate. So now what we're going to look at, what is the total number of payments? Well, if they call it, it's only 10, comma. What is the PMT? Well, that did not change. That's the 40, comma. What's the present value? That's the price we paid. That did not change. However, what did change was the future value. The future value is the price to call. Close it up. And then I have to multiply that times 2 because that would be the interest rate each per 6 months. So if they call it, it's 4.8%. And all they want to know here is what's the difference between the yield to maturity minus the yield to call. And that's how they're shown right there is the difference between those two. All right, next is McHugh's Incorporated bond currently sells for 1,080. I'll plug that in. 1,080. Coupon payment. That already has it. It's an annual payment of 90. So just keep that in mind. We don't have to calculate it. Just gave it to us, and keep it in mind it's an annual payment. So it's not per twice a year or every 12 months or anything like that. Par value, always 1,000. How many payments per year? Like I said, is only 1. Years are 30. Total number of payments would be the 30. Now we can find out what is our yield to maturity. I'll say equals when we do the rate. I don't have to multiply times anything. The payments are in yearly, so the yield, the rate will be year. So total number of payments is 30. Our PMT is 90. The present value, we paid 1,080. The future value is the 1,000. That's what we get at the end. So that's 8.27. However, they could call it within 5 years. That would be a total number of payments of 5. And then the price to call is 1,040. That means if they end the contract soon, they have to pay you for that difference. So I'm going to type in rate. Number of payments was 5. PMT did not change, 90. The price what we paid, that did not change. However, the future value is the price to call. So 7.70, and all I'm going to do here is find the difference between those two values. All right, Keenan Industries has a bond outstanding with 20 years. So I'm going to put that there. Kind of go as we go. It's 20. A 9% nominal coupon payment. That's coupon 9%. So we want to plug that in at the coupon rate. Semi-annual payments, that means twice a year. That means we're in 6-month intervals. Always keep that in mind. Par value does not change, 1,000. Yield to maturity, it requires a 5.77 nominal yield to maturity. So plug that in. And then coupon payment. So what does that mean? Coupon payment is 9% of par twice a year. So $45 per 6 months we were paid. Total number of payments would be 40. And then we could find out the price of the bond. That would be the present value. So we want to find the rate. Remember, we got to divide it. Since these payments are in semi-annual, twice a year, I have to find the interest rate. Yield to maturity is an annual. I have to divide it by 2. Total number of payments, 40. Our PMT is, oh, I don't think I, there we go. PMT is the 45, and then the future value did not change there. Now we got the price. So yield to maturity, I require 5.77. It means I'm willing. Why am I willing to lose money on capital gains? Because they're paying me 9% coupon. They're paying me a lot more in my interest payment. I only require 5.77. So I'm willing to lose money on the capital gains. So now, since we have price, we can find out what the yield to call is. So that's the tricky part of this question. We have to solve the price. It was not given. So called years, that would be 6. They can call it. Called price was 1,034. Total number of payments till call. So that's 6 times 2. That would be 12. And then we could find out our yield to call. That's going to be the rate. Total number of payments for the call is 12. PMT did not change. The price did not change. Future value did change. That's the 1134. That's the price to call. It's not going to be correct, right? 1.92 because these are semi-annual payments. Well, that is the interest rate every 6 months. I have to multiply that times the periodic payment. And then we got 3.85. Okay, last question. We're looking at a yield to maturity, a yield to call, expected return. So hopefully this is good practice. We've done it before. So I'm going to go kind of quick on this. So we have 1,100 for the price. If you didn't light up green, I'm trying to teach you a lesson that it has to be negative. Again, you could type it up any way you want, but when you plug it in the function, it must be negative. Coupon rate 6.35. Coupon payment. Before I do that, I'm going to put down the par. Periodic payments. This is annual. So it's going to be equal to 6.35 of par. I don't have to divide it by 1 because it's the same number. So we receive a annual payment of $63.50. Total number of years is 20. Total number of payments is 20. And now we can solve the yield to maturity, which is the rate. Total number of payments, PMT, price must be negative. So if you're doing this problem, you're just typing up in Excel, make sure that you put, if you don't put a negative in that cell, you can put it in front of the variable in the function. And then future value. Okay, 5.51. Now let's find out the yield to call. So what is the price? Well, the price is the same. It's kind of showed it. You could, if you want to solve it, you just got to plug that in. Coupon payment. What's the coupon payment? Well, that's going to be the same. So just a little practice over here to see how that works. Price to call. That's what we have to find out in the problem. That's 1,050. That's the future value. If they call early, that's what we receive. Years to call. This is 5 years. And now we could do the yield to maturity. Let me correct that before I forget. It's called yield to call. All right, so that's going to be the rate, which is total number of payments, PMT, the price, present value, and then the par value, which is the price to call, 4.95. And our expected return, we would say, is, I don't know if that would work. I might have to hit equals. What I love about Excel, just to show you real quick, I plugged in 5.51. That's incorrect. So you have to do that cell. All right, that's it. Just solved it. Any questions, please send me an email. Hopefully this helps you do it. If you don't understand it, I would recommend just to delete it and then redo it. Just redo it again until you truly understand it. All right, God bless. Thank you.